Welcome. This is the second lesson in our series on atomic structure. We're looking at compounds, mixtures, and equations today. I wonder if you can do a quick think back to the previous lesson and remind yourself of what the structure of an atom looks like. Have a quick think for 10 seconds. There you go. So last time we saw that the atom has a nucleus. Within that nucleus, we have a number of particles. Now, these particles could be positive protons, and then they might be neutral neutrons. So we'll give them a charge of 0. And those things are found in the nucleus. And then around the outside, we have our electrons. So if we put 2 electrons in our first shell, and then if we had our third and final electron in that second shell, because remember, the protons and the neutrons must be the same. There must be the same number of protons as electrons because atoms are neutral. Okay, that's a quick recap over some of the stuff covered last time. What we are looking at today is being able to define the terms compounds and mixtures. Remember again, any words that are highlighted in purple mean that they are keywords that are found in the glossary of the textbook, and we are asking that you would define those keywords as you go along. We're going to be able to produce diagrams to represent atoms found in elements, compounds, and mixtures, and we're going to look at constructing word equations, but also balanced symbol equations. So I wonder if you can come up with the connection between these 4 things. We have a conical flask labelled HCl. There's a salt cellar. There is a vinegar bottle with vinegar in it. And then a jug of water. So what are all of those things? And of course, all of those things were compounds. Whilst they were all things that maybe we've got in and around the home, maybe not hydrochloric acid, but there's some of that in your stomach, but they're all examples of compounds. So purple keyword, a keyword to find the definition for, and it's in this green box here actually. It says a compound contains 2 or more elements that are chemically combined. Now I think there's a really important word missing from that definition, and it's the idea that a compound contains 2 or more, and there's a word that I would add extra in there, 2 or more different elements that are chemically combined. So this first task, how many compounds can you name? Give yourself 20 seconds to name as many compounds as you can come up with. Maybe press pause now and come up with as many as you can. There we go. I would say, off the top of my head, we've got compounds like water, compounds like carbon dioxide, methane, ammonia, getting a bit technical now. We've got things like the hydrochloric acids that we use in the lab, and maybe something else you might remember like sodium hydroxide. They are all examples of compounds. Okay, not to be confused, say you might have thought something like O2, oxygen, or chlorine, Cl2. They are not compounds. Whilst there's 2 things joined together, they are not different. And that was the whole point of what I was saying earlier on. They've got to be different in order to be a compound. So, another task here for you. Can you match the compound name to the formula? So you've got the name in the blue boxes, and then you've got down at the bottom in green, you've got the possible formulas of those things. I would be having a periodic table to hand if I was you, because then you can see the symbols that relate to these things. For example, you might not remember what copper is on the periodic table. Okay, pause the video and have a go. So here are your answers. HCl is hydrochloric acid, H2SO4 is sulfuric acid, CO2 is carbon dioxide, NaCl is salt or sodium chloride. People quite often get confused when they write out NaCl. They think the Cl is a C for carbon and an I for iodine, so just be careful with that. CuSO4 is copper sulfate, and H2O is that really common one that we hopefully know already, which is water. So, compounds. Let's have a look in a little bit more detail. Once the chemical formula is known, it's easy to state whether it's an element or a compound. If it was a compound, we can find out which elements it contains because we would use our periodic table. Every time there's a capital letter, it signifies there is a different element. The number of atoms can also be calculated. For example, if we had sulfuric acid, so we've got a capital H for hydrogen, a capital S for sulfur, and a capital O for oxygen. So there's 3 different elements, but then there's some little numbers. The H2 means there's 2 hydrogens. S doesn't have a number to the right and below it, so there must just be 1 of them. And O4, so there's 4 oxygens. So 2 hydrogens, 1 sulfur, and 4 oxygens. 2 plus 1 is 3, plus 4 is 7. So there's 7 atoms in total of 3 different elements. Okay, so the next task, the Earth is made up of lots of different substances, and each of these substances contain elements. First one then, can you define the term element? What is a compound? So essentially, what's the definition of a compound? And then air is a mixture of the following. There's nitrogen, oxygen, argon, and carbon dioxide. How many elements and atoms are there in carbon dioxide? Pause the video, try and answer those questions. The answers are coming up. So here are the answers. An element consists of one type of atom only. A compound, as we said earlier, contains 2 or more elements which are chemically combined. And again, ideally, I'd really like there to be the word different, contains 2 or more different elements. And then the question about carbon dioxide, there are 2 elements because there are 2 capital letters, so capital C for carbon, capital O for oxygen. And then in terms of how many atoms, really common mistake with this one is to say that there's just 2. And because people quite often think that little 2 is saying how many of everything there is. So they either say there's just 2, a carbon and an oxygen, or they say there's 2 of all of them, 2 carbons and 2 oxygens, but the little number is only attached to the element on its left. So there's 1 carbon, because that doesn't have a little number next to it, and then there's 2 oxygens, because there's a little 2 next to it. So we need to look at mixtures now. We've looked at elements on their own and compounds on their own. So they would be pure substances. If you just had iron, lots of iron atoms, then that would be just pure iron. If you had lots of water, H2O, it would be pure, it would just be water. But now we look at mixtures. So a mixture consists of 2 or more elements or compounds that are not chemically combined. So, for example, air is a mixture, as mentioned previously in the question. So there's carbon dioxide, oxygen, nitrogen, water vapour. There's also all sorts of other things in our atmosphere, like the element argon and the compound methane, CH4. So a little extension task just here, if you've got some time, research the composition of the air. Whilst we've said what compounds are there and what elements are there, but what percentages are there of each of those gases? Okay, elements, compounds, and mixtures is what we're interested in now. So we know what an element is, we've got the definition of a compound, and we've just come across the definition of a mixture, but now we need to represent them in diagrams. Now we call these particle diagrams. And so we've got one on the left-hand side, which is an element. Now, you might be looking at thinking, well, that's a bit weird because there's two red balls attached to each other. That's fine. We can have that. That would be just like the element oxygen, for example. So oxygen hangs around in pairs. We call that a diatomic. It could also be something like nitrogen, N2, or chlorine, Cl2. Now, a compound, as we've said, is two or more different elements joined together. Now, here we've got a blue ball surrounded by two white ones. So there would be three things in total. Now, that could be something like H2O, where we've got an oxygen in the middle and two hydrogens around the outside. Or it could be something like CO2, so a carbon in the middle and the oxygens on either side. But really, because they're showing the white balls as smaller, it's probably likely to be something like H2O, because hydrogens are a lot smaller than oxygen, but the other way around, oxygen's actually bigger than carbon, so that would be not necessarily the best diagram to draw. And our mixture on the right hand side has got all sorts of stuff in it. There's some maybe something that looks a bit like H2O just there, something that could be N2 just there, something that could be O2 just there. What else have we got? We've got something in there that's a bit like our CO2. So maybe when we've got water, nitrogen, oxygen, carbon dioxide, that could be a mixture like our air. And in fact, if you look very tiny there, it does say the word air. So in another extension task, try to find out a pure element, a pure compound, and a mixture in your house. So have a look around, see what objects and things you've got. Can you find a pure element, a pure compound, and a mixture? Maybe just pause the video and have a think. I think a good example of a pure element could be something like copper. You've got copper coins. Technically, there's iron in the middle, but we could have the pure copper around the outside of the pure iron in the middle. A pure compound, something that's just one thing. If you had the right setup, you could get pure water in your house, because the tap water isn't pure. It actually has a few ions and things dissolved in it. But if you had the right distillation equipment, you could get pure water. And then a mixture, well, I've already mentioned water having things dissolved in it, so that could be a good mixture. So, balanced symbol equations. Now, formulas and equations show what is happening in a reaction. Word equations give the names of the reactants. So if you've ever wondered this and not quite been sure, the reactants are the things that react together. So that's the things on the left of the arrow. And the products are the things that are produced. So that would be all the things on the right of the arrow. And a symbol equation just takes the symbols straight from the periodic table. So we might have an element like magnesium reacting with a molecule of the element oxygen. There's two oxygens just there. And that goes on to make magnesium oxide. So magnesium oxide is MgO. But this equation just here is not balanced. And the reason is, if I write it underneath, there's only one magnesium on the left, but there are two oxygens. And then on the right hand side, we've got two magnesiums and we've got two oxygens. So we don't have what we call a balanced symbol equation. So balanced equations involve keeping the numbers of atoms the same on each side. So when we say each side, we mean on each side of the arrow. So we now have two magnesiums and we have two oxygens on the left hand side, and on the right hand side, because we've got MgO and another MgO, again we have two magnesiums and two oxygens, so it's now balanced. So here's an example. In the exam, you'll usually be given a symbol equation and then be asked to balance it. They will usually put a little line, just like this one just here, to say, right, that's where we want you to insert the number. Now, if we look at the reactants and the products, so remember I said we're talking about before and after the arrow, so reactants on the left and products on the right. For each element, is the number of atoms the same? Okay, so zinc, there would be 1 on the left and 1 on the right. They're the same. Chlorine, there's only 1 on the left-hand side, whilst there are 2 chlorines on the right-hand side. And the same with hydrogen. There's only 1 on the left, but 2 on the right. So, can you place a number in front of an element or compound in the formula to balance the equation? Remember, a number in front of the formula applies to the whole formula. So what that means is a big number means that you've got twice of everything after it, 2 lots of it. So you may need to add more than 1 number until the things are balanced. Now, in this equation, you don't need to. We just need to put a 2 just there. That gives us 2 hydrogens on the left and 2 on the right, 2 chlorines on the left and 2 on the right. And there was only 1 zinc on the left and the right to start off with anyway. So there we go. So we've got the right balancing for zinc, but we didn't have the right balancing for hydrogen and chlorine, so we had to put a 2 in place to work that through. So have a go at balancing all of those. It looks super complicated, but just deal with each one at a time. Just deal with the before the arrow and after the arrow. I would always start from the left and count how many there are. Maybe you want to write underneath how many there are on the left and the right. And just, I quite often like just putting a little arrow, not an arrow, a little line down there just to separate the left-hand side from the right-hand side. So pause the video and have a go. Right, there we go. There's your answers. 2 sodiums were needed to balance out the 2 on the right. Everything else was the same. Question number 2 was similar. We had to put a 2 in front of the NaOH, the sodium hydroxide, to make sure that we had 2 sodiums on the left for the Na2 on the right, and that we had 2 hydrogens on the left because there was 2 hydrogens on the right. But actually, in this one in question 2, you have to take into account the fact that there's some hydrogens here and hydrogens here, but on the right, the hydrogens are all in the water. So you have to be super careful to look back and make sure you've got all of them together. Okay, 3 was fairly easy. Oh, apologies for not putting a subscript just there. Never mind. 4 was a little bit tricky, but again, it's just counting everything up. Make sure you've got the same amount of things before the line, before the arrow, and after the arrow. Okay, that's the end of the lesson. Just like the previous lessons, create a brief summary of the lesson in your notes, whether that's at the bottom of the page using bullet points, whether it's to briefly summarize all the key points onto some kind of post-it note and to stick it in the bottom of your page, or whether it's to make some nice flashcards of the key terms, maybe have all your keywords and definitions on flashcards, maybe in this lesson you write out lots of different compounds and you state how you work out the number of atoms and the number of elements. Maybe you draw particle diagrams of an element, a compound, and a mixture of elements and compounds, finding some elements, compounds, and mixtures in your home as well. So there we go. That's an end of another lesson.